Hello, thank you for checking out A1 Math, and today we're looking at graphing exponential functions, part 1. And what I want to talk about today is build upon the knowledge of graphing exponential functions and talk about the end behavior and predicting what type of end behavior is based on the parts of that function. So here we know that our major basic function is y is equal to ab raised to the x. And right now I'm going to talk about the a and the b and what happens when they're different things. So here, if your b is greater than 1 and your a is positive, your function looks like this. If a is negative, your function goes down like this. Now, if your b is between 0 and 1, looking like a fraction most likely, and your a is positive, it goes down like this. And if your a is negative, it goes like this. So if you take a look at the example given here, y is equal to negative 3 times 2 raised to the x. The negative 3 is the a, and it's negative. And the b is between, or so it's greater than 1. So since you see that, you can tell that it's going to look more like this here. And that's what you got when you graph it. So we'll take a look at graphing some and see what type of end behavior we have. And I'm going to talk about end behavior in just a second, okay? So we're going to take a look at this first one here. And I've covered how to graph or how to figure out what your exponential function is when you plug in x with a calculator and with pencil and paper. So you can look at my previous videos to check that out. But I'm going to plug each one of these in and fill out this chart first. Then I'm going to graph it, and then I'm going to talk about what A, B, the y-intercept, and the end behavior is. Okay? So if I plug in negative 2, that can't be seen. Alright, so I'm plugging in negative 2 for my x, and when I do that, I get negative 16. When I plug in negative 1, I get negative 8. I'm going to try the skinnier one here. So when I plug in negative 4 or plug in 0, I get negative 4. And finally, when I plug in 1, I get negative 2. Okay, so now I'm going to graph the points. I'm going to plot the x and the y here. So when I go to negative 2, I go down to negative 16, which is here. When I go to negative 1, I go to negative 8. At 0, I'm at negative 4. At 1, I'm at negative 2. Okay, and because it's an exponential function, it'll never cross this line here. So we'll go ahead and try to graph it here. And that's what we got. Alright, so now we're going to fill out everything over here. The a, well, we know that from our y is equal to ab raised to the x. The a is negative 4. The b is 0.5. Okay, so if we look back, we see that the a is negative and the b is between 0 and 1. So that will leave this type of graph here. Now, the y-intercept. It's the same thing as with linear functions. Your y-intercept is, what is y when x is 0? Well, when x is 0, y is -4. So the y-intercept is 0, -4. Now I'm going to talk about end behavior. And it's exactly what it sounds like. It's like as you go toward the end, or at the end of your function, what type of behavior is going on. So we're going to do it in two ways. We're going to go all the way to the left and all the way to the right. So when it says x approaching negative infinity, as far as you can go to the left here, what you think is going on with the graph? Well, it's getting closer and closer and closer to negative infinity. Okay, so as you go to the right, though, it's getting closer and closer and closer to 0. Okay, so that's end behavior. Let's take a look at another example. All right, so again, here we've got y is equal to 2 times 5 raised to the x. If we look at our original chart here, we see that the a is positive and the b is greater than 1. So it should look something like this here. So let's take a look. So when I plug in -1, it'd be y is equal to 2 times 5 raised to the -1. When I do that, I get 0.4. Y is equal to 2 times 5 raised to the 0. And that's going to get you 2. And then y is equal to 2 times 5 raised to the 1. That's going to get you 10. And 2 times 5 raised to the second is going to get you 50. Okay, now I'm going to go ahead and graph those points. So you go to -1 here, and then go up 0.4. So that's like, if you got a decimal, the best way to think about it is like money. So 0.4 is like 40 cents. It's almost 50 cents, so it's almost half of it. And the way this is graphed here, it's going to be really, really, really small. So the best you can do is put a dot like pretty much on the line. So at -1, I'm going to put a dot here. Okay. 0, we're going to go up to 2, which is about right here. Okay. At 1, we're going to go up to 10. And at 2, we'll go all the way up to 50. So our line is like this. Okay. All right, so now we'll go ahead and label our parts here. So A is 2, and B is 5. And the y-intercept, again, is when x is 0, what is y? So when we plug in 0, we get 2. And now we're going to do the end behavior. So as x goes to negative infinity, what is the function doing? Well, it's getting closer and closer and closer to 0. And as x approaches positive infinity, going this way, it's starting to go straight up, but it's slightly going to the right a little bit at a time. And if you just keep going, it's just going to keep going to infinity down this way. So that's going to be positive infinity. And that's pretty much it. That's graphing a exponential function, part 1. And this is talking about finding A and B, y-intercept, and the end behavior. I want to thank you for checking out N1 Math. Have a nice day.